All right, welcome to today's Explainer. We're jumping right in, because if you're out there building complex AI systems, you already know the pain. That fragile, prompt-first mindset, it's hitting a massive brick wall. So today, we're breaking down how to completely move away from that endless probabilistic guessing game and shift into protocol-driven development. We're going to unpack the architecture you need to stop treating AI like some magic app generator and start treating it like a specialized, restricted builder operating under strict structural law. So let's start with the literal headache we've all experienced. Why exactly do long AI chats inevitably collapse? You've absolutely been there, right? You're feeding it a massive document, maybe a technical manual, or you're deep into refactoring a giant codebase. You're working through what feels like a 35,500-line chat history. You've got this perfectly, painstakingly prepared prompt, and then, boom. Right around prompt 50, the whole thing just falls apart. The system forgets its own architecture, it drops the context, it wildly hallucinates, or worse, it overwrites a perfectly good module with complete garbage.
To understand why that massive chat collapse happens, we have to talk about something called epistemic debt. Look, LLMs at their core, they don't actually do logical deduction. They're just guessing tokens. They guess the next most statistically likely word. And honestly, that's amazing for writing a quick email. But when you are building complex systems, small probabilistic errors in those early reasoning steps, they compound exponentially over time. It's kind of like a massive game of telephone. A tiny little misheard whisper at the start literally becomes complete gibberish by the 100th person. This is exactly why even the most state-of-the-art models like Claude 3.7 or OpenAI's o4, they will all eventually fail after hundreds of dependent steps. The epistemic debt just gets way too high, and the system collapses under its own weight.
So here is the stark divide we're looking at today. On the one side, you have the prompt-first paradigm. It's probabilistic, stochastic, and honestly, you pay a massive hallucination tax just trying to herd digital cats. It is incredibly fragile. On the other side, we have the protocol-first paradigm. This is deterministic. It's schema-enforced, it has zero entropy, and it relies on verified mathematical certainty. It basically shifts all the burden of control away from the model's guessing engine and places it into a very strict local architecture.
Section 1. The Generative Chat Collapse, Reaching the Trust and Coherence Ceiling.
Because when you operate without those strict architectural boundaries, you are just inviting generative chaos. These are the most common and frankly infuriating failure modes of just relying on prompts. You get these beautiful but completely non-functional interfaces. You watch the AI just overbuild the entire architecture before you've even proven a simple workflow. We get what the industry is calling AI slop. Fake dashboards and placeholder logic masquerading as finished features. You completely lose state management. And the absolute worst part? Destructive rewrites of perfectly functioning systems just because the AI probabilistically felt like changing the cosmetic layout on a whim. Which brings us to Section 2, the protocol shift, from guessing to governing.
To really initiate this shift from guessing to actually governing, we're drawing heavily from the architectural thesis of Solomon's Forge and Caleb AI. And I want you to internalize this single fundamental quote. Prompting asks an AI to produce an answer. Protocols define how an AI must operate. This right here is the pivot point for your entire development mindset. We have to stop trying to write the ultimate perfect prompt to coax some magical answer out of a black box and start designing a governing architecture that forces the AI to operate within strict, verifiable bounds.
Okay, so how do we actually govern? The Solomon's Forge doctrine lays out a very specific build sequence. Number 1, intent. Define what you're actually building. Number 2, workflow. Define the smallest end-to-end user action. 3, schema. Lock down your data structure. 4, engine. That's the non-visual intelligence. And only then, step 5, interface. The golden rule here is wisdom before construction, schema before surface. Because if you let the AI build the shiny interface before the workflow and the schema are totally locked in, you are practically guaranteeing a fragile app.
Section 3. Schema-first state management, breaking reliance on fragile chat history.
The absolutely crucial takeaway here is that the schema has to be the app's persistent memory. It is the one and only source of truth. When you force the AI to define that canonical data structure before any major UI work begins, you actually solve that memory loss issue that plagues those massive 35,500-line chats. The interface should really just be a dumb surface that reads from and writes to the schema. The exact second you let the UI become the hidden intelligence of the application, where it's relying on the LLM's stateless chat history to remember what state a user is even in, you are 100% destined to collapse.
Moving into Section 4, verification gates and hollows, keeping execution local and deterministic.
Enter what's known as the hollow server methodology.
Instead of immediately paying for a live backend or burning just ridiculous amounts of LLM tokens to simulate backend behavior, a Hollow server intercepts requests locally. It uses native browser tech, things like local storage, IndexedDB, web workers, to create this server-shaped void. So it keeps all the work local, totally bounded, and deterministic. And the best part? It lets you prove out massive, complex workflows without spending a single dime on provider API costs.
And this philosophy scales all the way up into full agent orchestration. It's perfectly captured in this quote from the Caleb AI framework. Models think, Hollows work, Caleb orchestrates. This is a total control inversion, right? Usually the AI model is the control center deciding what happens next. But under this protocol, a deterministic logic engine owns the loop entirely. Models are just stateless, fungible consultants. You ask them a question, they give an answer, and they stop. They never ever get to steer their own execution.
So if models are just consultants, that means everything they generate is treated as untrusted by default. And that brings us to the trust ladder. Any raw output from an LLM enters at T0. It is tainted, it's untrusted. If it actually fits our data structure, it bumps up to T1, which is the absolute permanent ceiling for model output on its own merits. And just for the record, two models agreeing does not promote trust. To reach T2, a deterministic hollow, meaning local code, has to independently verify that output. Then it climbs to T3 via strict policy checks and provenance, until it finally reaches T4, which is human approval. This entire flow is what we call the verified return path.
Now you're probably thinking, doesn't this verified return path slow everything down? Actually, it's the exact opposite. Take a look at the verification cost asymmetry, or VCA data. When you use deterministic, gated verification on structured outputs, you can verify claims in constant time. We're talking around 4.2 seconds. But if you try to verify untrusted, ungated, probabilistic outputs, like some massive AI-generated wall of text, the verification time goes super linear. It takes drastically longer. By simply enforcing protocols, you gain a massive 15-to-1, sometimes up to 47-to-1 economic and temporal advantage. Determinism isn't just safer, it's quite literally faster.
Which leads us to Section 5, Mathematical Document Control, Replacing Institutional Trust.
Zero. Just zero. This represents the zero entropy law. In a protocol-first architecture, entropy essentially means contradiction. And under this law, contradiction must equal exactly zero. If the system encounters conflicting data or a proposed reasoning step that violates its core schema, it doesn't try to probabilistically guess a way out of the problem. It immediately halts to a null or zero state. It actively chooses failing safely over hallucinating confidently. And this fundamentally changes who or what we actually trust. Historically, we relied on institutional trust, the whole "don't be evil" mantra, right? Just trusting that a platform or an AI wouldn't mess with our files. But now, through systems like the Covenant Protocol, we move into cryptographic trust. The mantra becomes "can't be evil." It essentially uses a SHA-256 digital meat grinder to mathematically enforce document integrity. It tracks every single change in an append-only ledger and guarantees bit-exact reproducibility. You don't actually have to trust the AI at all, because the math proves the work for you. So the ultimate takeaway from all this source material? Trust the math. We are fully entering an economy of verification. Your success in building complex, massive-scale AI applications is not going to rely on generative aesthetics or, having a slightly more clever prompt than the next guy. It's going to rely entirely on immutable structural validity. You have to put the work where it can actually be verified. Which leaves us with one final, critical question for your very next build. Are you still prompting for answers, or are you architecting protocols? Because if you want your systems to truly scale without collapsing in on themselves, it is time to stop guessing and start governing. Thanks so much for joining me on today's Explainer, and I'll see you on the next one.